GM, y'all. We're stoked to have you with us today as we delve into the new data paradigm. This discussion promises to be an insightful exploration of cutting-edge decentralized data solutions, focusing on the dynamic landscape of data management, interoperability challenges, security innovations, and scalable storage. At Textile, the creators of Tableland, our mission has always been to advance the decentralized web through innovative data solutions. Tableland is an open source, permissionless cloud database built on SQLite, enabling dynamic interactions and interoperability among digital entities. Our latest project, Basin, is designed to provide secure, verifiable, and scalable data storage, supporting developers in harnessing the full potential of decentralized technologies. Today, we're excited to hear from leading experts who are at the forefront of this transformation. Jonathan Victor, co-founder of Ansa, which explores the distributed infrastructures redefining how the internet operates. Jonathan will also be moderating our discussion, drawing on his extensive experience to help us journey into the heart of decentralized data challenges and opportunities. Joshua Noble, co-founder of Filebase, an interplanetary development platform providing all the tools you need to build the best decentralized applications on IPFS. Nandit Mehra, founder of Lighthouse, a permanent file storage protocol that allows the ability to pay once and store files forever. David Whittington, infrastructure architect at Permanent Data Solutions, or PDS, building a suite of Web3 apps and infrastructure that power the permaweb, the permanent decentralized internet. And Kanishk Khurana, DevRel lead at Fleek, giving developers everything they need to seamlessly build Web3 apps and services that are edge optimized for performance. So with that, we'll thank you again for joining us, and I'll hand it over to Jonathan to kick off the discussion.
Thanks so much. Yeah, I'm super excited to be chatting with everyone. I think, at least for almost all of the panelists, I chat with you on Twitter every now and again. So excited to be talking live, perhaps for the first time. I guess maybe to sort of like zoom out for a second, I'll give my definition perhaps of how I think about like this new data paradigm, but then I would love to actually go around the horn and just get everyone else's take. So I think for everyone who's in this space and definitely all the builders, we think quite a lot about why decentralized infrastructure, why like do all of this crazy Web3 stuff to begin with. And to me, a lot of the promise starts with interoperability. When I think about why this space is important, it's less so about like purely just saying like decentralization for the sake of it. It's really thinking about how do we build applications that are more resilient than any individual cloud provider, any individual protocol, and more hopefully like composable and interoperable. And so I think for me, at least in my journey, when I started with IPFS and Filecoin, a lot of it came back to this idea of content addressing, creating references for data that could be sort of like agnostic of any individual platform, any individual provider, that could be used across protocols and so on. So maybe that as like a jumping off point is an opportunity to maybe pull the panelists here. And maybe Nandit, I'll start with you. I would love to hear a little bit about how you think about the new data paradigm. What does it unlock, and sort of like what got you pulled on this space to begin with?
Cool. Yeah. So, hello everyone. I think hope you can hear me. But yeah, excited to be here on this Twitter space. I think Jamie, what you mentioned, some of these things around resilient, composable, interoperable infrastructure. Those are some of the key primitives in this new data paradigm. I think what got me pulled in initially was the fact that I think I was reading this article like few years back that okay, I can store my data and potentially like some identification data of citizens on and the example at that time was related to like some of the bombarding in Syria, and I was quite as an engineer at that time excited about the idea that okay, what if we distribute our data to other places across the world. So that was like the first key interaction where I thought okay, decentralized storage is something of a cool paradigm that I need to explore more and dive deeper. Although parallelly, some of the new ideas that keeps me tightened up is this concept of like no vendor lock-in that I'm quite excited about some of the interoperable elements where let's say if I can store my data on a storage system like Filecoin, I can use one client to store my data, but maybe use another client or interface to get my data back. So I think those interoperability elements are super important that I don't get vendor locked in where let's say in case of something like AWS or Google Cloud, I have to pay like a lot of I think I was just reading something recently where it's like around 61% of gross margin that AWS makes. And I think that's more primarily because of the vendor lock-in that these economies have been able to create. But I think overall, the fact that in this new data economy, we have these concept of distributed decentralized storage, now CDNs, databases, and much more. And the fact that I'm not logged into one single um, provider, that's quite exciting. And then parallelly, I think also that I can build an application where I can take somebody else access control system, somebody else's CDN, and then bundle them that together. That just helps in like lowering the overall cost. And yeah, the less vendor lock-in is something that gets me excited, although may not sound like that exciting to hear about.
Well, I mean, you sort of briefly touched on this in terms of like the applications and people using IPFS sort of for like the resiliency and I guess implicitly the uncensorability. David, I know there's a lot of interesting things people have done. I think it was with Apple Daily during the Hong Kong protests to archive sort of like different parts of that newspaper's backlog. Would love to hear maybe from your perspective how you think about the new data paradigm and sort of some of the more specific parts of the Arweave ecosystem that sort of address that.
Sure. Happy to talk about that and happy to be here. So, interoperability, I think, is really important. That's been mentioned before. I like to think of it a little differently, though, in terms of the terminology used. I prefer to talk about location independence. So I think a lot of the structural things that drive us to be stuck with our existing vendors is, we're addressing things at a location. In other words, when I'm talking to AWS, I'm talking to AWS. This is true of the internet at large. Like when I go to a website, DNS is going to resolve to an IP. And so I think the core thing to shift that is to address things by value, which, in and of itself is not new. Like that existed before crypto. But once you combine that with incentive systems that perpetuate the storage of these values through time, then I think we start to get really interesting systems that are sort of autonomous and independent of the entities running them. And so that's, I think, the core primitive behind all this. And, within the Arweave ecosystem, there's definitely a lot of focus on preserving history, making sure that content that might be censored in some regions, it continues to be available. But I think there's a lot of other applications you can build too. So my background is in database infrastructure, functional programming. And what really got me into this is just this idea that, like, the reason I don't know if this is getting like too technical for the audience or something, but the reason we do functional programming, right, is because it's hard to think about values that are changing. And I really want that in the large, right? If we have values that are changing on the internet, it's really hard to make statements about them that are meaningful over time. So I want to be able to refer to things based on the content of the data. And then we can build interesting knowledge systems based on that. So that's kind of what got me into this. And then, of course, you got to build out all the infrastructure to make that happen. And so that's what we're working on now.
That's awesome. Maybe Kanishk, I can bring you in here. I know Fleek, you guys think about very similar problems as you're building out your CDN. So maybe if you want to weigh in.
Absolutely. Am I properly audible?
Yeah, I can hear you.
Awesome, awesome. So yeah, hey everyone, thank you so much for having me here. My name is Kanishk, and so yeah, Fleek has actually moved one step beyond just being a decentralized CDN, and is now a general purpose edge network. Now, the way we look at this, the new data paradigm, is actually in a lot of ways, but the most prominent ones are threefold: accessibility, robustness, and availability. Which means that whatever data you want and whatever you want to build using your own data should be available to you at any moment that you want it. Data should be verified, and you should only get the data you requested to ensure that there are no malicious or wrong actors in your own ecosystem. Now, it also means that whatever systems you're building, they need to be perpetually scaling to ensure that your applications and the systems you develop stay for a long period of time and can serve a large amount of users. So essentially, it just means that as we store data perpetually on solutions like IPFS, we must unlock developers that are joining the ecosystem to build solutions that actually enable whatever they want to build. And we've seen some amazing use cases come through in the hackathons and the events that we've done, and just unlocking them with our tools and with the platform that we are building. So yeah, that's sort of my take on the new data paradigm and how Fleek as like an on-chain cloud platform can support all of this moving forward.
That's awesome. And maybe Joshua, to pull you in here as well. I know Filebase, you've sort of built a layer on top of a number of storage solutions, or at least previously you have. Would love to hear how you guys think about this as well.
Absolutely. Thanks, John. And thanks, everybody else. Glad to be here. Um, at Filebase, we are very much kind of like a Web 2.5 layer, if you will, as like an easy on ramp. And IPFS for us has been a big investment over the last year and a half, 2 years. We've used just about every network out there you can think of: SIS, Skynet, Storage, Arweave, etc. But IPFS, we've really doubled down pretty hard on for really about three key concepts, and some of them we actually use internally in building our own infrastructure and services. First one being content addressing. I think pretty much everybody on this call knows what that is, but obviously being able to address content by what it is or how it's encoded versus where it resides is tremendous. And then leveraging that for enhanced redundancy and resilience. We use this internally. We provide, as an example, we provide dedicated IPFS gateways as a service through our own file-based CDN. But when we run all these nodes to power all this infrastructure, we actually leverage protocols like Bitswap internally in case some of our own internal servers go down. And so we actually have fail safes in place that are actually powered by some of these new, in this case, Bitswap, a data exchange protocol. But that provides us internal resilience to ensure that our public service offering is highly available. And then the last key concept would be interoperability, the ability to take a piece of data, content address it, and pin it on your own local node, pin it on a service, pin it somewhere else, maybe a storage provider, over GraphSync, over Bitswap. But being able to fetch that data from really any node or gateway within the IPFS ecosystem and soon to be many other connecting ecosystems, that interoperability concept is key. And when you compare that to a traditional Web 2 world, I mean, people talk about AWS and vendor lock-in, but I think we do take a step back and be realistic here. Just about every Amazon service, there's an open source equivalent of today. And certainly when it comes to S3 compatibility, everybody under the cloud from Backblaze to Oracle has an S3 compatible service. So the key benefit here is these tools work across ecosystems, but you can't access an Amazon S3 bucket from a Backblaze b2.com URL, right? And so with IPFS, you can do that. And with Arweave, you can do that. And so this interoperability concept, I think, is really key and is really what allows a lot of these new projects, what attracts a lot of these new projects to build and allows them to really thrive.
Yeah, and maybe just to dovetail on that, I would love to hear maybe, and I'm sure the audience would as well, some of the war stories as people have been like building across Web 2 and Web 3. Maybe Josh, actually, if we could just pick up where you left off. I'd love to hear maybe a little bit more about some of the challenges that you guys have run into as you've been building sort of across these different solutions. And maybe if there's any opportunities you'd flag of like, what are things that could exist that maybe need to exist that collectively we could all work on?
Yeah, the biggest one for us that we've mostly solved, and I'll talk about how we solved it, but the big one for us is really content discovery. Just because you've content addressed data doesn't mean you can plop that IPFS CID into any gateway and it will actually load. Traditionally, for the last 4 or 5 years, that's been done through, you pin a piece of data, and then your IPFS node will typically make a DHT announcement known as a provider record, throw it on to the distributed hash table, and then other nodes on the network kind of listen for that. And then they kind of have a pointer record that expires, within 22, 24 hours. But that record tells them, hey, go over to this node to find that. It's kind of like a provider hint. And when you're doing that for a few hundred or a few thousand files locally, it's not so much of a problem. But when you're building a service like Filebase that's processing literally billions of files, it's very challenging because those records expire every 24 hours and you have to keep republishing them. And so one of the recent projects that's heavily leveraged in the Filecoin world that we employ quite a bit now is IPNI. Contact being one of the prominent public indexers. We run our own internal indexers as well, and we'll soon be sharing those endpoints for others. They can subscribe and listen to them. But in a decentralized world where you kind of break down some of these walls between silos, you do still have to establish some ways to find that data, because you're basically now in the solar system and there's no more planets around where they are, but they're so far spread out. And so you kind of have to know which direction you start heading to find content sometimes. And so that's a big challenge that we've had. Fortunately, we've pretty much, I think, solved it at this point. But we struggled with that for quite some time. And I know that we're not the only users in the IPFS ecosystem to do so. So I'm curious to hear what others have to say on the matter, just in general.
Yeah, well, maybe Kanishk, I can ask you this. Like building an edge
Sure.
network here, I'm sure you guys have dealt with this as you're pulling and caching data from other networks. So yeah, would be curious how Fleek is sort of addressing this problem.
Absolutely. So the way we do this at Fleek is that we actually have a core component called the fetcher. And the fetcher enables us to be extremely modular in terms of where we want to pull data from. All we need is a content addressable source. And once the data starts getting pulled, we do Blake3 hashing on the data. And then the data is cached around all the nodes. Any use case, which means any application or any service on top of Fleek network, can actually use that particular data because it now is in the block store of the nodes. These are all concepts that we've written extensively about in our blogs and our documentation. So if anybody is curious to learn more on them, please let me know. I'm happy to dive deeper into that. But essentially, what I'm trying to say here is that being modular to us means attaching ourselves into any ecosystem and being very plug and play in terms of providing that performance boost. And that is how we've actually been able to achieve it. So simply just pull, do Blake3 hashing to make sure all the data you receive is verified, all the data you receive is secure, and then ensure that any application on top of you is able to utilize that in whatever source and form they want. In this entire ecosystem, there's also these services that I just very briefly mentioned. And what we can do with these services is take the same data we've pulled in and do any sort of computation you want to do on the data. Now, as the data moves forward to an application, you can build your own Fleek functions, which are essentially edge functions that can perform computation on any amount of data that has been pulled. You can bring your Next.js applications on chain and actually make sure that its implementation and performance is boosted by the Fleek network. And you can, upscale all your development through Fleek. So yeah, that's basically how we've looked at this problem, how we've tried to solve it. And I'm very happy to say that we are 7 times faster than AWS, about 2.7 times faster than Vercel. And the new testnet is coming in about 2 weeks. So everybody will be able to try all of this out.
Wow, that's amazing. Maybe Dave, do you want to give us some color? I know your team also runs the R.io project. So yeah, I would love to hear more about how the Arweave ecosystem thinks about this.
Yeah, exactly. The RIO project is my main focus, just scaling out gateways and access to Arweave. So let's see. I think I'll talk about two things here. Our main focus right now is to make sure that we can scale the gateway network within Arweave, and so provide sort of Arweave native access, and everyone who wants to run a gateway can run a gateway and participate in. Sorry, getting notifications here. Should have muted that. Can participate in our gateway network and just have the ability to run gateways on Arweave. So that's our main focus, and you can think of that as sort of sufficient decentralization and interoperability of gateways within Arweave. Now, there's a step beyond that, which would be interoperability with the broader crypto storage ecosystem, and I think that's something we'll be wanting to push on over time. Some of these things, like if you're already in the IPFS ecosystem, I think there's a lot of network effects there. For people who are not in that ecosystem already, I think you run into things that are sort of cultural barriers. So crypto can be kind of tribal. And the individual ecosystems don't necessarily always have an incentive to reach outside of themselves. I think probably the long-term solution for that is to just get more serious applications being built on these things, because my background is more traditional software, and I can tell you that, like, enterprises are going to view a lot of these individual crypto networks as risks, and they're going to want to mitigate the risk, and so they'll be looking for interoperability solutions. But as of right now, I think we're still very early, and there's less pressure on that. So some ecosystems can get away with being a little more insular, but I think the market forces will change that over time, and we're happy to continue to support those efforts as they manifest.
Maybe Nandit, do you want to sort of round us out on this topic? Yeah, I know building across IPFS and Filecoin, you probably have some perspectives too.
Yeah, sure. I think from our perspective, at Lighthouse, we are building like permanent storage on Filecoin network, and there are three primary things that we focus on a lot. First is like the crypto native primitives and what all does that enable. For example, how we leverage Filecoin right now is we are able to provide our users this 24-hour what we call as proof of space time, this which is like a deterministic guarantee from the miners to the end users that yes, your data is there, and if even if someday we as a layer go away, you can still fetch your data out of the network. So there's that cryptographic part, and definitely there are more strong proofs on the network like proof of replication. Another one that we also implemented recently, which is proof of data segment inclusion, so that we can verify user even like a tiny file of 1 KB that yes, your data is stored over a period of time with these 24-hour proofs that miner gives to them. Another part of this crypto primitive is composability with other parts in the ecosystem. For example, using the power of Filecoin virtual machine, we have an on-chain endowment pool that, unlike other storage protocols out there, we can also lend to DeFi protocols like Glyph, which is a Filecoin lending pool, and even cross-chain to Aave and Compound. So like any real-world university and endowment would work that invests their fund over time, like Lighthouse and our endowment pool on FVM, we're able to lend it to crypto native DeFi protocols like Glyph and Aave Compound. So that is the crypto native part, primitive part that I'm quite excited about. The other second part that as a team we are quite excited about is the security part. Like at Lighthouse, we implemented this interesting cryptography SDK called as Lighthouse Kavach that essentially uses the power of BLS threshold cryptography, and it essentially solves two problems for the end user. One is that the user experience, that your data is not stored at your private keys is not stored at one location, but it's distributed across multiple locations. So this is the security part, and the user experience part is more like the clients need not manage keys on their end. So let's say you can token gate any file on Lighthouse with an on-chain logic. Like if you own one Pudgy Penguin on Ethereum and 1,000 Aave tokens on Polygon, then only you can view the file. So that is very interesting that unlike right now, Filecoin, RV, etc., they don't provide private storage, but that just eliminates more than half of the use case that developers want, who they think understand cryptography, but essentially doesn't. So that is the second part, or after like crypto native primitives and uh, like the security part that I'm excited about. The third important part that I'm quite excited about is the whole user experience. Like at Lighthouse, um, we build like this easy to use dashboard, which is called as Lighthouse Files, that you can let's say log in through your GitHub, Google login, even MetaMask, Phantom wallets as well, and soon coming to Cosmos chain as well. And the fact that you can, easily pay using crypto on, let's say, Filecoin, Polygon, and even pay using Stripe. People just love that, like as an easy onboarding solution. And the fact that they can on our dashboard see and verify that there are these storage proofs. Like just imagine Google Drive, but now you can verify all of these things, that where your data is located, which miner is storing. Recently, we started making storage deals with the miners, which is like for 3.5 years, which is like amazing. When users comes in, they're like, oh, wow, I can actually see where my data is being stored. How long is this miner storing my data? If it goes out, then Lighthouse replicates again. So yeah, those are the three things that we build Lighthouse at the core with: crypto native primitives, access control security, and third on the user experience part.
Well, that's awesome. That actually leads into the question I wanted to pose to everyone next, which is, so I think there's a lot of real powerful primitives that having these sort of like open and interoperable networks brings to sort of like end users. There's also sort of a double-edged sword there, where when you have a content hash, that's something that people can get much more, I guess, maybe gun shy about, especially when we talk about like enterprises and anyone honestly who's thinking about like data privacy along with these sort of open networks. I'm curious how people have thought about this as they've been bringing solutions to market, both either in a go-to-market, whether that just be like focus on fully public data sets, or even thinking through how to sort of like incorporate various forms of encryption, or whether that be sort of like threshold networks to sort of like re-encrypt or using crypt trees and things like that. I'd be curious how people have been thinking about layering in privacy on top. I guess, Nandit, you already sort of talked a little bit about the Lighthouse sort of approach to this. Maybe Joshua, if you want to comment, if this is something you guys have given any thought to.
Sure. Encryption and privacy is pretty paramount. We actually took this pretty strongly, not that we don't anymore, but we really enhanced this quite a bit a little over 5 years ago when we started Filebase. We started life as the first layer 2 solution for the SIA network, actually. And everything on SIA is erasure coded and encrypted by default. And the whole goal of the Filebase platform at the time was to effectively sell cheap and deep object storage, leveraging SIA for cost effective backplane, and then going against Wasabi and Backblaze B2s of the world. And so being S3 compatible, we have this concept of like bucket accessibility. A bucket's public, it's private. There's ACLs for objects and buckets. And so if a bucket is public, it can be public, it can be private, but we really had to limit data quite a bit there. With IPFS, that obviously changes the game quite a bit. We still have this, and this is obviously project specific to Filebase at its core, but we still have this bucket layer of accessibility where a bucket can still be private, and that kind of takes claim to how list object calls work with S3 API and things of that nature. But at its core, if you have a content hash or identifier and you request that, you're still going to get that content back. And so we make it very clear in the product experience of Filebase that when you're creating a bucket, everything on the IPFS network is public. And users have to agree and acknowledge that they've kind of read that disclaimer or warning. But it is a double-edged sword, and the enterprise word was already dropped a couple times during this call. And I can tell you, I spent two and a half years, sitting in calls with Fortune 500s and 100s, trying to sell them, decentralized storage for cost savings, and cost savings is the last thing on their mind. Reliability, availability, and security are the top three things the enterprise is going to care about. We're talking about non-crypto enterprises, right? And so I think Filecoin specifically and IPFS, there are going to be some challenges there, because if you have a DLI CID or a CID of any piece of content in IPFS, anybody's going to be able to retrieve that. And so now we're dealing with encrypting data, but that very much goes against some basic HIPAA and SOC compliance rule sets where encryption is not enough. You have to actually block access to meet some of these certifications. So there's definitely going to be a handful of enterprises that we're already working with, a bunch of them, who actually do need IPFS specific things. But I do think, unfortunately, there will be some areas in certain industries on the enterprise side that simply will not be able to use certain types of decentralized storage for these reasons. And I think that that's something that people are starting to realize a bit more, and we will see more of as time goes on.
Yeah, I mean, space. I mean, I will plug the Banyan homies. I think people should check out the stuff that they're building. Both WinFS and BanyanFS actually might be interesting, Josh, to take a look at, just for like using crypt trees on top of IPFS data. Basically, just like fully encrypt and then being able to use UCANs or something for access. And then I think the other piece of being able to sort of layer in like other retrieval protocols where you can do permissioned retrievals and things like that. But I think the path to enterprise definitely is going to require landing these features in a good way if you want to actually be able to address some of those higher value use cases.
I play with Banyan FS. It's actually really cool, and I want to explore it more. And I agree, that's a great way to delegate access to data and still make it publicly available. But again, the reality is, you're never going to be able to achieve HIPAA or PCI compliance if you can't list the street address and have physical control over the server where that data is stored. So there's like the crypto reality of like we're living in the Web3 world, and then there's the reality on Wall Street of like this enterprise is never going to use Filecoin at scale if they can't continue to meet their ISO 27001 certification or whatever it may be. So there's some challenges there on the enterprise side for sure.
Yeah, I agree. I mean, I don't think the answer necessarily is saying like, hey, you can't do these things. It's more like, look, you need someone like a Banyan or someone who may be able to offer those guarantees on top with subsets of the network. So, I mean, I do think it requires people understanding like, how do you bridge the Web 2 and the Web 3 worlds, understanding that there are like core requirements that aren't going to budge from enterprise.
Right.
But maybe, Kanishk, I'd be curious to know how you guys are thinking about this and sort of as you think about your go-to-market, what are sort of the ways that you think about privacy?
Yeah.
Oh, I missed the tail end. I missed the tail end of you, I think, there.
Did I cut out? I was just asking maybe how are you guys thinking about this from like sort of like the use cases that you guys are going after with an edge network and sort of thinking about privacy and apples on the Fleek side.
Yeah, absolutely. So for us, we don't discriminate between like, okay, Web 2 dev and Web 3 dev. For us, it's developers. But the second thing is that, I 100% agree that enterprises and big, MNCs will always say that, hey, my data's privacy is more important, and thus a public data solution doesn't really work for me. Which is why we thought of this problem and we felt that we need to expand beyond just being available for public data and go and have a place where private data can also be stored securely. And that is when we realized that all Fleek nodes will have something called SGX chips, which is the entire SGX chip inside them. And this would allow us to store the data inside the SGX chip, but still generate a proof of that data that can be stored in the block store that can be accessed by any application that uses Fleek. So inherently, your environment variables, all sorts of secrets that you may want to think about your application, or just any data that you don't want visible on the public ledger can live there, while just the proof of existence of that data can be stored and can be publicly accessed. So only if you have the proof and you have the decryption and encryption keys can you access it. And essentially, this is how SGX was our answer and our solution to implementing privacy and data security over and above of all the Blake 3 hashing that we are already doing. I've also seen Banyan's solution to this, and I believe that they're also doing a good job. And all these developments in this space actually benefit us a lot because Fleek, as a network or as an on-chain cloud, can sit on top of any of these providers and just scale performance and scale productivity for all of them. So that's the first thing we realized. Now, for an example, if you're building an edge function that actually takes your project ID and your project ID is an environment variable or something, then that ID can live inside your particular SGX chip environment. And just the proof of it is going to live on the block store. You can easily still access all the functions you want on the edge without hampering or sacrificing on any sort of privacy or data security. So this is how Fleek manages to solve this problem, and bring a solution that is viable for both Web 2 companies, Web 3 companies, enterprise solutions, MNCs. This is simply done so that we can cater to a larger bandwidth of users and become like a unified source of compute for them. And yeah, that's basically what we're doing.
Awesome. And maybe David, if you want to round us out, I'd be curious, especially in sort of like the permanent context, how you guys think about this too. Um, yeah, what's cooking on the Arweave side?
Yeah, it's a great question. So I sort of have two answers to this. We both have RIO, the gateway network, and we have a product called R Drive, which is, you can think of, there's a bunch of things in this space, right? But you can think of this as like a Google Drive type of application on top of Arweave. And in that, of course, we support encrypted drives, just using, actually, I don't work directly on that product, so I probably shouldn't say things that are too in depth there. But anyway, we support encrypted drives in that product. But then on the gateway network, we're basically saying, look, we're not tackling privacy initially. We're focusing on public data. I like following Banyan, what they're doing for sure. I think UCANs are super cool. I think that's a really hard problem though. And I do wonder, like, I appreciate all the efforts there. I think ultimately this space will get there. But I wonder if that's actually the right problem to focus on, because I do just think it's a really hard sell to existing enterprise customers. They're just going to be extremely paranoid because mistakes are so costly there. If you have data breaches or things like that, that's really, really costly for enterprises. So our solution is basically we're focusing on public data first. Now, on the data security side, we do have to deal with that, and there's a couple dimensions to that. One is just the data all needs to be verifiable, right? So if we have this gateway network, you don't want some gateway in there misbehaving and serving up, some interface that hijacks something. So we hash everything. You can compare hashes across the gateways, and then on the another aspect, I'm sure lots of IPFS gateways have to deal with this too, which is you have a permissionless data system. People are going to upload everything to it, and of course we want content to be accessible. That is, like, we don't want governments censoring things, like trying to suppress information. But there's fairly universally objectionable content that you don't want. And things like phishing sites, you don't want those things out there, or abuse content of various kinds. So we provide ways for people to moderate the content. Basically, you can just block things by hash or ID. And that's a very important thing. And also, again, as more serious businesses get into this, they're going to worry about the liability of having served any of that stuff. So that solution has to be very robust to not be storing or serving certain kinds of content, just to comply with laws.
Yeah, 100%. I know in the IPFS community, there's been a lot of work on building tooling for gateway providers to basically be able to determine their own list of what are the things that they want to put on their own block list, but then share that
Yeah.
with each other. One thing that would actually be interesting is figuring out how to do that across ecosystems. So if there's ways of translating Arweave hashes into their equivalent, like SIDs, that could also be useful, or vice versa. I don't know if it's a transaction hash, maybe it's not possible to go the reverse direction from a SID to an Arweave transaction. But if across ecosystems there's tooling to allow people to share sort of their opinions, and then gateways can make their own determinations,
Yep.
that could be really interesting.
That is definitely something we're looking at. And we've looked at the IPFS gateway standard there for blocking stuff, and are interested in adopting things where we can that will work across ecosystems.
Maybe to pull back a little bit, I know one of the things that I think almost everyone here has probably been experiencing is post 2021 boom of NFTs. I think now deep in networks, there's definitely a larger surge of data coming into these networks overall. I would love to hear some of the war stories people have had around dealing with scale. I think Joshua, you had mentioned you guys deal with 2.5 billion files. Would love to hear maybe a little bit more about how you guys have sort of handled sort of the uptick in demand for these services, and some of the sort of learnings that you've had.
Sure, absolutely. Yeah, that's the number you just quoted, 2.5 billion. That's file count, but as you know, IPFS shards everything typically into blocks of 256 kilobytes. So we're talking about hundreds of billions of individual blocks, and there's deduplication from block level dedupe and things like that. The biggest challenge we had was we were using off the shelf tooling. I'm sure everybody in this call on the IPFS side knows IPFS Desktop or Kubo, formerly Go IPFS, and so we were using tooling like that about a year and a half ago for powering most of our gateways and pinning and things, with a whole type of custom orchestration layer. We're a full bare metal Kubernetes shop across the board, in all of our edge locations, and it got to the point where we're the number of uploads we're processing per day, per hour, per second, just simply exceeded the amount of thresholds that Kubo and other stacks similar to that we've tried IRO and other things as well, could support. And so we ended up adopting many of the libraries from the greater IPFS community, notably being JS libp2p and Helia. And we kind of wrote our own kind of custom stack, very somewhat similar in nature to some of the Elastic IPFS stuff that Web3 storage team and the guys they outsource the development of that to. So it's very much similar to that. But we've had to build a custom stack from the get-go, that kind of we could scale statelessly, store that data into our kind of data backplane in different edge locations, but then more importantly, tie it all into IP&I for announcements and routability. And a large part of that was adopting standards to make that happen. So one of the big standards that we really followed through on was really taking advantage of content archives, CAR files. in storing things as car files and being able to dedupe across at the car level. But that really gets into a conversation around the trustless nature of IPFS and how there's a big push now in the interplanetary community to really work on trustless gateways and fetching raw blocks and fetching raw car files. And I think we're going to see a lot more developments come on the client side and application side in regards to those trustless request cycles. But that's something internally that was a big battle that we faced. And for now, we're lights on, scaling ahead, but was quite a challenge at the time. When you have errors going off left and right from exceeding thresholds, and your NVMe drives are maxing out at gigabits per second, and all hell's breaking loose. So fun times ahead for sure.
100%. Yeah, I think almost every team I know that was doing IPFS at scale probably a couple years ago was really having some stressful moments. But I think definitely I've seen a lot improve over the last couple years as people have been building out and rolling out more solutions. Maybe David, if you want to talk a little bit, I know like I've seen some of the charts from the Arweave side, transaction volume going up and to the right. I'm sure there must be similar challenges that you guys have run into as well. If there's anything interesting you'd love to share, I think we'd all be keen to hear.
Oh man, yes. A lot of scaling challenges. So the background here is, we're building this gateway network, but we also run arweave.net, which is the main access point that a lot of people are using. So we're trying to scale on multiple fronts here. Let's see, what of interest can I say here? So first of all, we're up to, I think, 5 billion or something like that, transaction-like things, combination of actual transactions and data items in Arweave. And so that's a lot of stuff to address and index. So we're dealing with the internal, challenges of scaling the main access point to do that right now. But I think the more interesting thing from the RIO network perspective is like, how do we deal with this in the permissionless, decentralized network we're trying to build? And our philosophy is maybe a little different than some other teams in that we really want to be able to scale down really small. So we think a lot of applications, and I can tell you because we see all the data and we index it all, a lot of applications are only accessing a tiny subset of this data. And what we want to do is make sure that everyone who is building an application or a protocol or whatever on top of Arweave has the tools they need to access and index the data they care about. And we think if we do that, that's actually a much better solution to a lot of the performance problems, because each individual team then, well, maybe walking through a scenario would be good, right? So if you have a team that's building a medium scale application, they might be running their own gateway, indexing and serving access to all the data they care about. And then at some point something happens, right? Like the team goes away or they run out of funding or whatever. If the infrastructure they have is small enough that another team can easily pick it up, small enough and standardized enough and open source that another team can pick it up, then that thing will most likely survive if it has users, or maybe even the users will run it. Using our own application, R Drive as an example, you could run a little gateway that is only indexing your R Drive data and participating in this network. And then you don't have to rely on any other team. So in a lot of ways, we're starting from the scaling down perspective of just providing things that can easily index and serve subsets of the data. And then we think over time, more scalable indexing solutions will emerge, because there's a lot of ways you can protocolize indexing in particular that are pretty interesting. But the starting point is just to provide tools that individual teams can use to survive bad things happening to them.
Yeah, that's a super interesting approach. I know, Nandit, you've been working on things like Podzy to deal with like very small files, and I'm sure you've also seen.
Oh, Jonathan, I think your mic's a bit off. Can't hear you great.
Oh, is this
There you
better?
go. There you go. Yeah, better.
God, Nandit, I was just trying to tap you in here a little bit. I know you've been working on things like Podzy and doing proof for small data, and I'm sure that's exploded in size as well. So yeah, I would love to hear if you have any learnings from the Lighthouse side that maybe you can share with the group.
Yeah, I think just to resonate with others, we also at Lighthouse do face similar issues in terms of scaling, like the data and the traffic that goes through IPFS, and then the speed as well. Like with us, like the clients come for various needs. Some have like needs of like, okay, we want to stream like 4K video of your system, and then some are like, okay, we just want to back up like these NFTs as we are working with the NFT storage team, and then the NFTs has to be there forever. And then something on the later part, what becomes important on the Falcon network on how it works is that miners have this what we call as sector sizes, and that could be like 32 GB or 64 GB sector size. That below that, it's not that economical for the miners to store data. So what Lighthouse we focus on a lot is, okay, how do we bundle and aggregate your data collectively in the right format, so that the miners first of all accept those files and it becomes economical for them. But parallelly, we provide this pod sci proof, which is like proof of data segment inclusion. What it essentially means is that now you have a proof of even a 1 KB file into that 32 GB bundle, and then you can in future retrieve that small KB file as well. So I think, yeah, like some of the issues that we are working on right now is clients bringing a lot of different sizes of data. Some would bring like a million or 10 KB files, while somebody would bring on like tens of GBs of large blob of data. So how do we bundle and aggregate them together? That's also something that we are actively working on. But yeah, like there are some other limitations, like as Joshua also mentioned around IPNI on how does the data gets indexed correctly. Like Filecoin nodes, especially the Filecoin Boost nodes, can also now talk to the IPFS network. So we are actively seeing, okay, how can we use this PodSci proof so in a way so that these small files can be retrieved directly from the Filecoin network and then indexed onto the um, broader IPFS network using IPNI. So that's a very interesting problem space. And then something that David also mentioned around phishing. I think every day we also get a lot of requests on, let's say we got a request from a Spanish government recently, like from a Japanese authority, that can you take down this phishing site? And then it's a peer-to-peer network, but then yeah, what we do from our side is take down from our own gateways. But yeah, those are some interesting problem space that we are onto right now. I'm quite excited. And I think your point is quite correct that we should be working on it together on having these standards. Like the first question you asked at the start of the space on maybe like how does RView transaction hashes work with CIDs? How even like CIDs here can work with other storage protocols? That could be something very interesting that we are lacking maybe as an industry. Then, but if we start to focus even like our 20% efforts on, okay, how does my permanent storage solution works with somebody else's database solution or CDN or edge network, that is something I think we should also start exploring as an overall one Web3 infrastructure team.
Yeah, 100%. I know we're getting close to the end, and I do want to make some time for us to open the floor up. So maybe if people want to start requesting if they have any questions for the panel, but Kanishk, since I didn't get a chance to ask you this last question, maybe I'll start with, I have one more question I want to pass to everyone, so I'll pass this to you. Uh, so we've talked a lot about where we've been going or where we've come so far. I would love to hear maybe your vision for the future. What gets you excited? What's on the horizon? What maybe are things that everyone in the panel or the audience could be looking forward to coming out of Fleek or generally for the Web3 space? And then if people want to request, we'll have your questions come up after the rest of the panel answers that question too.
Absolutely. Like at Fleek, we're making some big moves recently. Today is actually a very big day for all of us because we just got the handle at Fleek. So we're no more Fleek XYZ on Twitter. We are now simply Fleek. And this marks a very big move into what we want to present and what we want to become. It's just like your one-stop solution for on-chain cloud usage and on-chain cloud needs. Um, the testnet is coming in 2 weeks, which is another thing that we are working towards very rigorously and making sure that everything is end-to-end tested, everything scales, and we just stand with developers. We have about 100,000 websites already deployed in the last 4 years that Fleek has existed. And yeah, like to everybody's point in the last question, we've had our fair share of phishing, malicious users, and malicious intent all over. But moving forward, we sought that out to be a very big problem. And, with all the verifications and Blake hashing computes that we were able to build out, we are actually trying to mitigate a lot of those problems now. So, yeah, for us, be excited because the testnet is here. You can make your own edge functions. You can build them into your own applications and make sure that they perform faster and give you better results than any centralized counterpart. More and more support will be built in the coming time. We are doing a hacker house in Brussels. So if anybody is interested, it's going to be like one of the first tweets in my own account and Fleek's account. So you can definitely check the hacker house out. And yeah, we're doing 2 hackathons in June as well to support you and to help out everybody that's building. First is the on Summer Hackathon with Base, and second is HackFS at Eat Global. So a lot of big moves happening, and I'm really, really happy and excited for what the future holds for us. Thank you.
That's awesome. Maybe Joshua, you want to go next?
Sure. Future looks pretty bright on our side, and I think really for the future of IPFS as a whole. We've been having a lot of discussions with a number of, I would say, AI communities and machine learning model LLM communities, and we're starting to see a lot of this data come online. This is traditionally from the Web 2 world, building LLMs, putting it onto IPFS and pinning it, making it available. But then, of course, we're even seeing decentralized Web3 type projects like Jensen, for example, who are focused on distributed machine learning, and they are also starting to write to IPFS and other distributed and decentralized storage networks. So I think we're really looking to forward to the new challenges that it will take to distribute some of these data sets, which are pretty large in size. But that's probably the top thing on our radar for now.
That's awesome. Maybe Nandit, you want to go next? Or if you're going to be up, there we are. Oh, I think we lost Nandit. Maybe Dave, you want to go?
Sure, I'll go. Yeah, I too am really interested. So I'm a little skeptical in things that are doing like inference or training in the Web3 crypto world. I don't know. It might work, might not. Hard for me to say right now. But data sets, I think, are really really interesting application. In particular, like I think building up data sets by composing different data over time is very interesting. Because we should have an advantage in this space, right? Like I never feel comfortable with the idea that Hugging Face has all this data and like we're all reliant on Hugging Face. Like, wouldn't it be better if we just posted that all on these permissionless systems? And then over time, data sets could just refer to each other and you can have composite data sets. So I think that's really cool. Another thing, I don't know if this is, well, I'll just throw this out there and maybe people can react to it. I think games are a very interesting application in this space. And I don't mean, there's crypto games where they're highly tokenized and incentivizing things. And I do think there's real stuff in that space too. And that's interesting. But I mean games where the players just own a lot of the content. So, way back in the day, I used to play MUDs, which were these text-based multi-user adventure games, right? And then later it was evolved into things like World of Warcraft. People get really, really invested in those games. And I think there's probably space for people to build worlds like that they don't necessarily have to be super tokenized or anything like that. They can just be community run. And that's an interesting niche in my mind, because if you think about going against existing players, like cloud providers, it's a thing I don't think that really makes sense on top of them. Like they're not gonna, there's not that much, the market for that is not huge, but the people care about a lot. So I think you could actually drive a lot of initial adoption that way, because it's just a market segment that no one else cares about. So I haven't convinced myself that's a real thing, but it intrigues me as a person who has played these games and like built games in the past. So we'll see if it happens. I guess I would add one other thing too, just along the lines of like data sets. I think knowledge graphs on permissionless data systems are really interesting. Like I would argue part of the reason semantic web didn't take off, I mean, probably multiple reasons for that, is just because of the mutability of the references in it and the reliance on individual servers standing up. I think we have a much better chance of building large scale enduring knowledge graphs on these permissionless data systems that are addressing things by data. So I think that's a really interesting thing over the long term. I don't know exactly how it's going to take hold, but I think if we can make these systems work well, it probably will eventually.
Yeah, 100%. Especially on the gaming, for what it's worth. I've been thinking about this a fair amount. It's hard for me to tell if maybe we're just like a little bit too early, but I think also this trend of AR and VR, I think it like gives you the platform to have digital collectibles, which could be things. I mean, like as a kid, I had Hot Wheel cars, but like you could imagine having like a 3D rendered version that just sits on your desk, but then also like an actual racing game like F-Zero or something. And so I
Right.
feel like we might be like one cycle too early for it, but I'm very optimistic for that future, where it's like these digital objects you can like actually do stuff with.
My kids buy a lot of stuff in Minecraft, so there's just definitely some market for that thing.
Nandit, I know we lost you for a quick second, but if you want to maybe round us out, unfortunately, I think we actually hit the end of the space. But yeah, what are you excited about? What are you looking forward to?
Yeah, I think from our side at Lighthouse, some of our focus in coming quarters is even making the Lighthouse protocol permissionless. That will involve two parts. One is our all endowment pool contracts on Falcon virtual machine controlled by a DAO, and then the underlying nodes of bundling, aggregation, and access control, not run by Lighthouse team, but then other teams, ecosystem teams outside ours as well. So yeah, that is one of the things that I'm quite excited about. But parallelly, although I want to see more and more penetration of Web3 technologies outside Web3, but um, I think there's a fair amount of work to be done just bringing the Web3 categories onto Web3 itself, because still they are relying on old traditional infrastructure, including things like social, Web3 social, Deepin, and then even the whole crypto AI space is quite interesting as well.
Awesome. Thanks so much. I don't know if from the Tableland side there's any closing words you have, but I just want to say thank you to all my fellow panelists who are up here. It's not always you get to, sort of like chat with people across different parts of the decentralized storage ecosystem. So really, it was a ton of fun just to hear sort of like what you guys are focused on and how things have been materializing on your side.
Yeah, thanks so much, guys. It was a great conversation. Appreciate you taking the time.